All right, so today our objective is that by the end of today, you will know and understand that the value of both sides of an equation must be equal at all times. Solving an equation is a process of finding a number or numbers that make the equation true. The addition property of equality as well as the subtraction property of equality, what those are and what they mean. And by the end of today, our big key goal is that once you know and understand all of this, that you will be able to solve one step addition and subtraction equations. All right, so I provided these notes for you. Today we're going to talk about solving an equation, I don't know why I keep trying to say 1 and 2, addition and subtraction equations. So solving an equation is like balancing a scale. So both sides must remain equal. And I found that some kids your age don't realize what a scale is. Maybe they're less common than they used to be. So think about it like a teeter-totter. The heavier side will go down and the lighter side will go up. So in order for that teeter-totter to stay at the same weight or scale, if you do understand that, we need to have, or to stay at the same level, we need to have the same weight on both sides so that that balance can remain equal. So on this first one, we have a scale and it's set to level because both sides are at the same height. So we want to go ahead and make it so that this is true because 2 circles and 3 triangles are not going to have the same weight as nothing. So we need to go in and add 1, 2. Let's see if it'll draw them better for me. Oops. All right, let's add some 3 triangles. 1. We're going to pretend like those are the same size as the other ones, even though we know they are not, because this isn't liking me. All right, we're going to pretend like those are the same. 3 triangles. All right, and then 3 circles. And clearly mine are not the same. It came out way different. Does that look better? Better-ish. The triangles do not. All right. I'm just going to leave them. So 3 triangles. And for the sake of this, they're the same as the other 3. All right. So in order for this to be true, I have to have 3 triangles and 2 circles as well. And we're going to pretend like they are the same. So our addition property of equality and our subtraction property of equality, I've added them in red. I want you to go ahead and add this. So these kind of state that what I do to one side of the equation, I must do to both. The addition says what I add to one side, I must add to the both. And the subtraction property of equality says what I take away from one side, I have to take from both because they're equal. So what that means is if I add a star to the left side, in order for these to remain the same weight to remain level, I have to add a star to the other side. And that's the addition property of equality. What I add to one side, I have to add to both. And same thing goes with subtraction. What I subtract from one side, I have to subtract from both so that they remain the same. All right, so we're going to go ahead and look at the second one. Again, we know that 3 does not carry the same weight as 7 does. So what we're going to want to do is go ahead and figure out what I have to add to 3 so that it is the same as 7. So let me think, what adds to 3 to give me 7? Well, and we know that that is 4. And those balance scales are going to work exactly the same as these equations that we're going to look at later today. So if you're still copying those properties of equalities or filling in those, go ahead, pause this, fill it out. You got it? All right. You don't? Pause it? Okay. So now we're going to talk about how to solve a one-step equation. So the variable must be alone or isolated. So we know that variables are those letters that take the place of numbers. Well, today we're going to talk about actually figuring out what those numbers are and the process of how to do that. So in order to do that, we have to get that variable alone or isolated on one side by itself. So the only thing on that side is that letter taking the place of the number. So we can say x equals, and once we've solved it, we'll have a number. We'll know that's the value of our variable. So in order to isolate the variable, we must use our inverse or opposite operations. I added a 2.5 because I wanted to add that in here. So today, our first set of inverse operations that we will be talking about are addition and subtraction. Addition and subtraction are inverse operations, so they are used to get rid of each other. To get rid of addition, we're going to use subtraction. To get rid of subtraction, we're going to use addition because they're each other's inverses. And then 3, the equation must remain balanced. That is specifically what we did in these examples, what we talked about with those property of equalities. In order for that equal sign in the middle to remain true, in order for them to stay the same, what I do to one, I have to do to both. And then once we've gone ahead and used our inverse operation, so addition to get rid of subtraction and subtraction to get rid of addition, and we'll see what that looks like in a second. After we've done that, we can go ahead and plug the solution that we got in to make sure that it's true. So then we can also use algebra tiles. So today, to represent the equation. So we're going to go ahead, and they give us these algebra tiles. And your sheet doesn't, but mine moves. I set it up so it'll move so we can kind of see the math. So what it tells us in the key is that this big rectangle is our x, or our unknown value. And each of these squares represents 1. The y is going to represent addition, so giving 1. And the gray is going to represent subtraction, or taking 1 away. So in order to do our equation, we have to write what we have. Well, I have one x tile. I'm going to put x. We know that there's an assumed 1 there. We've been talking about that. And then I have 4 1 tiles. So x plus 4. It is equal to, then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 tiles. So the way algebra tiles work are that I can move them so I can visually see the equation working. So we know our subtraction property of equality states that what I do to one side, I have to do to both. So when I take these away, it's going to be like we're subtracting. So I'm going to subtract 1 from my left side. But what I do to one side, I have to do to both so that they remain equal. All right, and then I'm going to go ahead and again subtract 1 from the left side, but I also have to do it to the right. Subtract 1 from my left side, but I have to do it to my right, and I'm going to subtract 1 more from my left side, but I have to do it to my right, and then all I have left, and I'm just moving it over, is my 1x. So all I have left is x and its value. So I have x, because this rectangle represents our unknown, equaling to 1, 2, 3, 4, 5, 6. So our unknown, or our x, is going to be equal to 6. And we just visually, with our algebra tiles, our squares to represent algebra tiles, we solved that. We subtracted from both sides by physically subtracting those squares. Now let's go ahead and look at one more together. So, someone moved my squares. Oh no. All right, and I'm going to pause you just so I can make sure that that is the same as yours. And it was a good thing to check. So this is what yours look like. I changed them so I could move them. And I went through it, and I guess I didn't move them back. All right, so we're going to go ahead and we're going to write and solve the equation represented below. So again, I see 1 unknown, so 1 x value. And I see 2 1 values, so plus 2. And then we have our equal sign, and then I have 1, 2, 3, 4, 5, 6 of the 1 tiles. So I have 6. All right, so that's our equation. Our unknown plus 2 is going to give us 6. So we can go ahead and do some more subtraction. I'm going to subtract one side from the left side. Oops, and I'm not going to make it an unknown. I'm just going to move it. Please let me move it. Okay. We're going to subtract 1 from the right side. And then I'm going to subtract 1 from the left side. If it'll let me move it this time, subtract 1 from the right side. So I've subtracted 2 from each side. Took out the squares representing those numbers. So now all I'm left with, and again, I'm just gonna let me move it over. I have our 1x tile. I have that it's equal to, and then I can just count how many I have left. We can visually see, if it'll let me erase and not scribble on it, that we have 1, 2, 3, 4. So we know that our x is equal to 4. So what I want you to go ahead and do, I want you to work this one out. Don't let it throw you off that the x is on the other side. We're still just going to pull the tiles. You cross through it on your sheet because you can't manually move them like I did to see how many you have left to get your equation and then solve it. Pause this, work that out, and then unpause it. You got it? Then pause it. Got it now? Cool. All right. So our equation, we have 1, 2, 3, 4 tiles. We have that is equal to 1 unknown value tile plus 1 we know is a 1 tile. All right? So we're going to go ahead and we're going to take our tile. We're not going to make it unknown because it wants to stretch it huge. But what I will do to one side, I have to do both. And now I have my x value all by itself. So I have my unknown or my x being equal to 1, 2, 3. Get that? Is that what you got? Awesome. So let's go ahead and we're going to try subtraction. So this time the black squares are just representing that we're taking that away from our big unknown value. So our equation, we're going to have x minus, because we have 2 black squares, 2 equals 1, 2, 3, 4. And then we're going to go ahead and we are going to, did I copy that right? All right, so in order to undo taking away 2, I'm going to go ahead and I am going to add 2. So taking away this negative is like adding. So I'm going to add 2 to the left side. And that makes these positive. So in order to get rid of subtraction, we have to add. So we added 2 here. Minus 2 plus 2 made those positive. What I added to the left side, I had to add to the right. So what minus 2 gives us 4? It is 6. And then we're going to go ahead and do the same thing on our right side. I have our x value minus 1 equaling 1, 2, 3, 4, 5, 6, 7. So to take away minus 1, I have to add 1, which negates this lovely minus 1. So adding 1 means I'm removing minus 1, but I have to also add 1 to the right side, and I get 8. And is 8 minus 1 7? It is. So now we're going to go ahead and take a look at what this actually looks like with numbers and not the physical manipulatives. So what I'm going to go ahead and do, we have subtraction. So on my first one, we're going to remember 2 things. First, we're going to remember that our inverse operations are used to get rid of each other. So to get rid of subtraction, we use addition. To get rid of addition, we're going to use subtraction. And then we're also going to remember those addition and subtraction equality properties. What it says is that if I add to one side, I have to add to both, because the equal sign in the middle here says that the 2 are the same. So in the first one, I have x minus 6 is equal to 12. So my inverse of subtraction is addition. So what I want to do to get rid of that subtraction is add 6. But my addition property of equality says if I add 6 to that left side and I want them to stay the same, I have to add 6 to my right side. So minus 6 plus 6 cancels, and we're left with x on that left side. We're going to go ahead and bring down our plus sign, or not a plus sign, our equal sign, and then we're going to go ahead and add our right side. 12 plus 6 is going to give me 18. So we get that x is equal to 18. And then we're going to go back and check it. And we're going to check it by saying 18 is what we got. So x minus 6, because that's our original equation. And if we did it right, we're going to get the original answer that 18 minus 6 is 12. 8 minus 6 is 2. 1 minus nothing is 1. We did indeed get the same answer. So we did that right. Awesome. Okay, so now I am going to go ahead and do the next one. So this time we have addition. Still same thing. Addition and subtraction are each other's inverses. This time I have addition, so to get rid of addition, I'm going to subtract. And our property of equality states that if I subtract on this left side, so 5 minus 5, I have to on my right side, because this equal sign says my two are equal. If I take something from one side, in order for them to remain balanced like that scale, I have to do it to both. So 5 minus 5 leaves with nothing, so I have just x on that left side. Those cancel. And then we're going to go ahead and bring down our equal sign, and 11 minus 5 is 6. So we're left with x is equal to 6. Well, I want to go ahead and I want to check that to make sure I did it right. So in order for this to be true, at 6, which is our value for x, x plus 5 equals 11. So 6 plus 5 also has to equal 11. Well, if I add 6 and 5, I get 11. And I know 11 does equal 11. So I did that right. And I set it up so you could see the subtraction. But 18 minus 6 equals 12. We got 12. 12 equals 12. So we did it right. All right. So I'm going to go ahead and do the next one. So I have addition. I have x plus 3 is equal to 7. So we know that our inverse property of addition is subtraction. So we're going to need to use subtraction to get rid of that addition. And our subtraction property of equality states that what I do to that left side to get rid of that 3, I have to also do the right, because my equal sign says this side, this left side is equal to my right side. So if I take 3 from one side, I have to do it to both. So 3 minus 3 is nothing. So we're left with x equals 7 minus 3 is 4. And we can go ahead and check that. And I know that 3 plus 4 has to be equal to 7 in order for this to be true. And 7 does indeed equal 7. Okay? Awesome. I am going to do one more, and then I'm going to let you do these last 4 as well as the challenge. Because the only difference in the challenge is that they give you some decimals, and I know you love them. So we have subtraction. What's my inverse of subtraction, guys? Right. So we're going to go ahead and to get rid of minus 2, I'm going to add 2. So negative 2, positive and negative the same number. Minus 2 plus 2 cancels. We're left with x. And 15 plus 2 is 17. So we get that x is equal to 17. And then we're going to go back and check it. In order for this to be true, 15 has to be equal to 17 minus 2. Well, and I'm going to line it up just so you can see it. 7 minus 2 is 5. 1 minus nothing is 1. So 15 is indeed equal to 15. All right, so what I want you to do is I want you to go ahead and pause this. Pause it. Work out 7, 8, 9, 10, and challenge. Are you done? Then pause it. You done now? Cool. So we're going to go ahead and go over this. So on this first one, what did you do? Right. So our inverse of addition is subtraction. So in order to get rid of plus 4, I have to subtract 4. My subtraction property of equality states that what I do to one side, I have to do to both sides. Oops, why did it switch on me? All right. Oh, because I'm too high. All right, so go back down. I don't know why it set it to the top instead of the bottom. It went all the way high up, but now we're back to the right place. So what I do to one side, I have to do to both. So to get rid of plus 4, I have to minus 4. Well, 4 minus 4 leaves us with 0. That cancels out. So we're left with x. Bring down our equal sign. What is 17 minus 4? Well, 7 minus 4 is 3. 1 minus nothing is 1. So we get that x is 13. So then we're going to go ahead and we're going to plug it back in to check. So I get 17 equals 13 plus 4. So in order for this to be true, 13 plus 4 has to be 17. 3 plus 4 is 7. 1 plus nothing is 1. So 17 is indeed equal to 17. All right? Awesome. So how did you solve this next one? Well, it's addition. So what did we say our inverse of addition was? Yes, we subtract. So I have to subtract 4 to get rid of plus 4. Am I done? No, why not? Exactly right. Our subtraction property of equality states what I do to one side, I have to do to both. So 4 minus 4 cancels, and we're left with x on that side. We've isolated it like we want. And 11 minus 4 is going to leave us with 7. So x is equal to 7, and then we're going to go ahead and check it. In order for this to be true, 7 plus 4 has to be 11. And 7 plus 4 is indeed 11. 11 does equal 11. So we did it right. Awesome. So my next one, I have subtraction. How do we get rid of subtraction? That's right, with addition. So we're going to go ahead and get rid of minus 3 with plus 3. Our addition property of equality says I have to do that to both sides. Minus 3 plus 3 cancel, so we're left with x on that left side. 12 plus 3 is going to give us 15. So x is equal to 15. So we're going to go ahead and check that. 15 minus 3 has to be equal to 12 for this to be right. And 15 minus 3, 5 minus 3 is 2, 1 minus nothing is 1. And 12 does indeed equal 12. So we did it right. Awesome. And then the last one before the challenge, we have x minus 8. How did you get rid of that subtraction? That's right, we have to add. So we're going to add the 8 being subtracted to both sides. This cancels on the right side, and we're left with our x. We're going to bring down our equal sign, and 32 plus 8 leaves me with 40. So we get that x is equal to 40. We're going to go ahead and check that. We have that 32 is equal to 40 minus 8. Well, what is 40 minus 8? We can't take 8 from 0, so we have to borrow. So 10 and 3. 10 minus 8 is 2. 3 minus nothing is 3. We do indeed get 32 is equal to 32. Awesome. So then we're going to go ahead and do the challenge. Same process. The only difference is that it's got some decimals. So how did you get rid of this subtraction? With addition, we're going to go ahead and add 8.5 to both sides. I add it to both sides because of our addition property of equality. Make sure you line up those decimals. I didn't do it very clearly, so I'm going to fix it. Remember, 0.5 needs to go under 0.1, and my ones place needs to go over my ones, under my ones place. So I cannot take 5 from 1. So I had to, oh wait, this cancels. We were left with x, and then we're going to go ahead and do our addition. Go ahead and check myself. I'm trying to subtract. Get rid of subtraction. We added, so 1 and 5 give us 6. Bring down our decimal. 6 and 8 give me 14. And I got 24.6. Did you get that one right? You didn't? Did you not line up your decimal? Okay. So let's go ahead and check that. So in order for this to be true, 24.6 minus 8.5 has to be equal to 16.1. All right. So let's go ahead and see what is 24.6 minus 16.5. Make sure you line up that decimal. 6 minus 5 is 1. Can't take 8 from 4, so we're going to have to borrow. 14 minus 8 is going to leave you with 6. 1 minus nothing is 1. Does 16.1 equal 16.1? Does. Awesome. So, what I want you to do, so 10 tells us to summarize today's lesson. So I want you to think about what I told you had to learn. So this is just the general, this is what you need to know. I want you to explain that objective and how you achieve that objective in what you learned. Tell me about these different things. So we came in this wanting to know that the value of both sides of an equation must be equal. Why do we know that? We came into this knowing that solving an equation is a process of finding a number that make an equation true. What is that? How do we do that? What is that number that makes it true called? What do our addition property and our subtraction property of equality tell us? And what was that process of solving one-step addition and subtraction equations? What are their relationship? Go ahead and summarize what we learned today by telling us how we achieve that objective. Tell me what you learned. What is that summary of what you learned today? Awesome. That's all I've got.